Hi everyone, let's talk about the properties of real numbers. So there are 5 different kinds of real numbers that we're going to talk about. We have natural, whole, integers, rational, and real. Now over on the right hand side there's this other kind of number called irrational, and we'll talk about that in just a minute. First let's talk about the natural numbers. Now natural numbers, a good way to remember them is when you were really little and you first learned how to count, you would start by counting on your fingers and you would always start with 1. So that's what the natural numbers are. They're 1, 2, 3, 4, and all the way up. So, again, just remember that it's like you're counting fingers on your hand. Now the next kind of number are whole numbers. So there's not a lot of difference between natural and whole numbers, except that whole numbers also include all of the natural numbers as well as 0. So it's going to look like this. Okay, so now we have integers, and integers include whole numbers, natural numbers, as well as the negative parts of them. So an example would be -1, -4, 10, 0. All of those values are integers because they're whole and natural numbers, but they also include the negative parts of them. So now we've got rational numbers. Now rational numbers are any number that can be written as a fraction. Keep in mind that integers, whole numbers, and natural numbers can all be written as a fraction. Let's go back up to natural numbers just for a quick example. If I were to write the number 2 that you see there and put it over 1, it's now a fraction, which means rational, and therefore a rational number. You could also do the same thing with a negative number. So for -1, I could put that over 1, and it would still be a fraction, so another rational number. Now, rational numbers also include a lot of different other numbers. Numbers that don't give you an exact value, such as an integer or a natural number. Rational numbers are any number that can be written as a quotient. Okay? So we've got 3 different words here meaning fraction. We've got rational, we have quotient, and we have rational, the name of the word. So one example could be I have 1 over 2. That's an example of a rational number. Now keep in mind here also that the parts of the fraction, the numerator, the top, and denominator, the bottom, have to be an integer, whole, or natural number. Decimals have no place within a fraction. Okay? Neither do irrational numbers when we get there. So let's think of another one. How about a -1? Let's do -3/10. Okay? So as we can see, both the numerator and denominator are part of one of these guys' families. Okay? Each part has to meet that criteria. And we could also just write in here 121. That is also a rational number because it's also over 1. Okay? And therefore it's a fraction. Now, real numbers is like the umbrella that encompasses all the different kinds of numbers that we have written above. So real numbers are any rational, integer, whole, or natural number. So it could be any of those above. I could write -100, I could write 2, I could write 0, I could write 5/8, and those are all real numbers. So real numbers is everything above it. Okay? Now, let's move on to irrational numbers. Irrational numbers are kind of funky. There are 2 criteria that irrational numbers must meet. So the first criteria is that there is no repetition within the number. And keep in mind, irrational numbers tend to be really crazy decimals. Okay? So within those decimals, we don't want to see any repeating pattern. Okay? Unlike, for example, 1/3, which is a, which is a rational number, okay? 1/3 is approximately 0.33333, on and forever. So this has a repeating pattern. We can definitely tell just from what we see here that the rest of the digits here are going to be 3s. So that's a pattern, and that doesn't fit the criteria of an irrational number. Now, another example to show you what is not an irrational number, let's take 1/4. Okay? Now 1/4 is equal to exactly 0.25. Now, as you can see, the second criteria of an irrational number is not terminating. Terminating means to end, like the Terminator. Okay, he ends life. It's a depressing example, but that's what I have got. Notice that this decimal ends. Okay, it ends right after the 5. There's not a whole bunch going on after this, and that's what we need to see. So we don't want to see this, and we don't want to see this. So the examples I've got for you, a lot of irrational numbers tend to be rooted numbers. For example, the square root of 2. And the decimal approximation for this is what you see here. 1.4142135623731. So let's take a look at the criteria for an irrational number. First of all, you shouldn't see a repeating pattern, which I don't. I couldn't guess the next number if I wanted to. They seem completely random. The next thing is this decimal actually does not end. Those are all the digits that my calculator could give me. But there's many, many more after this, and the digits go on for infinity. It just doesn't end. So since it meets both of these criteria, it is an irrational number. Another example that you will find to be an irrational number is pi. Pi is a classic example, and that is approximately 3.141592653, and it just goes on and on and on. So again, there's not a pattern, nothing repeats, and it doesn't end. So both of these are different kinds of irrational numbers. But keep an eye out for those rooted numbers. They're typically going to be irrational, except for a case where it's like the square root of 4. Okay, because we know that the square root of 4 is exactly equal to 2. So the square root of 4 would not be irrational because when you simplify it, it becomes either a natural whole or integer value, which is exactly what I needed. So that's not what I need. Okay, that's not what an irrational number is. It fits all of these, okay, and the real ones too, but it does not meet the criteria for an irrational number. So those are your properties of real numbers. Thank you for watching.